This video covers basic probability definitions from the beginning of Chapter 5. The probability of an event describes the likelihood that the event will occur. It is always a number, and that number is always between 0 and 1 inclusive. An impossible event has a probability of 0. An absolutely certain event has a probability of 1. The closer the probability is to 1, the more likely the event will occur. We use capital letters to stand for events, and a capital letter P is the notation for probability. So let's go over a few definitions. A probability experiment is a procedure where there is some uncertainty about the outcome, and we carry out the procedure or simulate it in some way. Each time we carry out the procedure, it's called a trial. So, for example, we could flip a coin, and we don't know if it will land heads or tails, so this is a probability experiment. And every time we flip the coin, it's called a trial. The list of all possible outcomes of a probability experiment is called the sample space. The sample space is a list of what we call simple events. In later sections, we'll start combining simple events with conjunctions like and or, and these types of events aren't simple. Let's look at some examples. Here is the sample space for rolling 2 standard fair 6-sided dice. This is everything that could happen. I could write these as ordered pairs, or I can draw them out like I did here. Another example. Let's say I toss a coin 3 times to see if it comes up heads or tails. My sample space has 8 events in it, listed there on the slide. Next, we'll talk about the 4 ways to assign probabilities to events, and we'll discuss these 4 methods in the next slides. The first method we'll discuss is called the relative frequency approximation method, which is sometimes called the empirical method for probability. I tend to call it the relative frequency approximation method so we don't get it confused with the empirical rule for bell-shaped distributions that we learned back in Chapter 3. To find the relative frequency of an event, we conduct the probability experiment many times and count the number of times that the event actually occurs. Then we divide the number of times the event occurred by the total number of trials. This is the same concept we learned back in Chapter 2, taking the frequency and dividing by the total to get the relative frequency. It's called the relative frequency approximation because this method gives us an approximate probability, not an exact probability. My brother collects weighted coins. Coins with 2 sides, both heads and tails, but weighted so that heads comes up more often than tails. The way to make a guess at the probability is to flip the coin many times and see how many times it comes up heads. So suppose I flip the coin 1,000 times and it comes up heads 782 times. So my best guess at the probability of heads is 782 divided by 1,000, or 0.782. An important concept in probability is called the law of large numbers, which tells us that as we repeat the probability experiment again and again, the relative frequency approximation gets closer and closer to the true probability. So if we want a good estimate, we need to have lots of trials, and the more times we repeat the experiment, the better our estimate will be. I hear about the law of large numbers sometimes in movies or sitcoms. People who are gambling in some way will talk about something being due. They'll say something like, that coin has come up heads 10 times in a row, and the law of large numbers says that heads and tails has to even out, so this time it has to come up a tail. But this is false. That coin doesn't remember what just happened. Over thousands and thousands of trials, if the coin is fair, then it will even out to be a relative frequency of 0.5. Also keep in mind if the coin is weighted, like my brother's coins, then that probability isn't going to even out to be 0.5 or 50%. Next, we'll talk about another method to assign probability, a formula that will give us an exact probability. However, this method only works if all the events in the sample space are equally likely. If there are n equally likely things in the sample space, and if an event can occur in k ways, then the exact probability is k divided by n. Let's look at an example. Again, let's toss a coin 3 times. So that everything in the sample space is equally likely, this must be a fair coin. Let A be the event of getting 2 or more heads. There are 4 simple events that fit that criteria, and 8 simple events in the sample space. So the probability of getting 2 or more heads is 4 divided by 8, or 1/2, or 0.5. Again, let me emphasize this only works if everything in the sample space is equally likely. If I'm talking about my brother's weighted coin, and if I flip that coin 3 times, the probability of getting 3 heads is not the same as the probability of getting 3 tails. So I can't use this formula for exact probabilities. Later in this chapter, we'll learn some formulas that will help us to compute exact probabilities for more complicated situations like this one with my brother's coins. Let's do a few more examples with the dice. Let A be the event that we roll 2 fair dice and get a sum of 7. Let's look at the sample space. The sample space has 36 events, and they're all equally likely. In how many events do we get a sum of 7? You'll find these events down the diagonal, and there are 6 ways to get a sum of 7, so the probability of getting a sum of 7 is 6 over 36, or 1 over 6. What is the probability we get a sum of 12? Let's look at the sample space again. There is only one way to get a sum of 12, so the probability of getting a sum of 12 is 1 over 36. What's the probability that the sum is even? Again, we'll look at the sample space. What do you think? Half of these numbers have a sum that's even, so that's 18 over 36, or 1/2, or 0.5. What's the probability we get a sum of 1? Do you need to see the sample space? It's impossible to get a sum of 1 when we have 2 dice, so this probability is 0. Our third method to assign probabilities is called the subjective method, and the resulting probabilities are called subjective probabilities. In this method, the probability of an event is estimated using our knowledge of relevant circumstances. We use this all the time without even thinking about it. When I say that the Braves have a 50-50 chance of winning their next game, or when I hear someone say, there is no chance she's going out with him again, those are subjective probabilities. The fourth method to assign probability is by simulation. These days, simulation is done mostly with computers, but in this class, we will sometimes do simulation the old-fashioned way because I like the old-fashioned way. And sometimes people will use a combination of methods. For example, whether people will use computer simulations to predict the weather, and they also use their knowledge of relevant circumstances to decide how the computer models are working and what the weather will be. Being able to use these methods and being able to tell which method someone else is using are useful skills for this class, and we will practice this when I see you next time.